Every autumn, Washington state faces an enormous logistical challenge. As the epicenter of U.S. apple production, the region's orchards erupt with millions of tons of fruit that must be pulled from the trees in a tight, unforgiving seasonal window. For decades, the only way to get those apples down was by hand. Dozens of workers spent weeks climbing ladders, reaching into the canopy, and plucking each fruit individually. It was a massive physical undertaking, with soaring labor costs, capped entirely by how fast a human being could safely move. To speed things up, the industry introduced mechanical muscle. They deployed 10-ton shaker machines equipped with massive hydraulic arms. These rigs drive right up to the trunk, clamp down, and aggressively vibrate the entire tree, bringing hundreds of apples raining down in seconds. Once the fruit is on the dirt, a vehicle called a windrower drives through, sweeping the apples from the sides into neat lines down the center of the row. Right behind it, a pickup harvester uses rotating rubber fingers to scoop those lines of fruit directly onto a moving conveyor belt. The machinery allows a single crew to process 10 to 15 tons of fruit in a day. But that violent shaking and the hard drop to the ground heavily bruise the apples. Farmers are caught in a difficult position. The raw mechanical power solves their scale problem and beats the seasonal clock, but the resulting physical damage severely limits what they can actually earn from the crop. The apple market is split into two distinct tiers. The highest returns come from the premium fresh export market, while damaged fruit is diverted to the low-value juice and processing sector. A bruised apple cannot be sold in the premium tier. The moment that fruit hits the ground during a mechanical shake, it is automatically downgraded to juice grade, erasing a significant portion of the farmer's potential profit. To keep those profit margins intact and the fruit flawless, growers had to sideline the heavy machinery. They were forced right back to the slow, expensive process of sending laborers up into the trees to handpick their premium crops. Agriculture needed a completely different approach. The industry required a tool that could match the relentless day and night output of a commercial tractor, while perfectly mimicking the careful, intuitive touch of a human picker. The solution arrives in the form of intelligent robotic arms. These systems break the long-standing compromise between processing speed and product quality. Instead of blindly shaking a trunk, the machine relies on advanced optics. AI-powered cameras continuously scan the dense foliage, identifying the exact location of individual apples hidden among the leaves. The onboard computer evaluates the ripeness of every apple, processing visual data in real time to decide if it's ready. Once confirmed, soft mechanical grippers extend, applying precisely calibrated pressure to gently twist and pull the fruit without breaching the bruising threshold. A single unit can execute this sequence continuously, successfully harvesting thousands of apples in a single day, while keeping the delicate skin completely intact. By replacing violent shaking mechanisms with smart, targeted extraction, orchards can hit massive industrial harvest quotas without sacrificing their boutique-level quality. This level of precision doesn't stop at the edge of the orchard. The integration of intelligent robotics carries straight through the supply chain and into the processing facilities. Look at historical sorting methods, and you'll see massive operations that relied entirely on lines of human workers. They had to visually inspect thousands of crops as they flew by on conveyor belts, trying to spot defects by eye. Today, walk into a modern almond facility in California, and you'll find dedicated supercomputers running around the clock, continuously analyzing the incoming harvest. High-resolution scanning cameras inspect every almond on the line, looking for microscopic cracks a human eye could miss. When spotted, the software plots the exact coordinates and fires a signal to a high-speed robotic arm, which darts down and removes the damaged almond. The combination of advanced machine vision and instantaneous robotic execution guarantees the crop's premium grade is protected from the moment it leaves the tree until it is boxed for shipment. The evolution of farming equipment has transitioned from the raw, earth-turning muscle of deep plows to the surgical accuracy of machine vision. This precision allows farmers to capture the full economic potential of their crop by minimizing the bruising that previously forced premium fruit into lower-value processing bins. The ability of these machines to perfectly identify and extract a crop determines the final economic value of the entire year's labor. For a modern commercial farm, advanced computing power is now just as vital to their survival as tractor horsepower and seasonal rainfall. So the next time you walk into a grocery store and pick up a perfectly round, flawless piece of fruit, consider that it likely wasn't plucked by a human worker, and it definitely wasn't shaken to the ground by heavy machinery. It was carefully chosen and protected by a machine that can see.